In this video, we're going to look at some applications with operations and functions. So we're going to look at the profit, revenue, and cost functions. So for this first example, it talks about gymnast clothing manufactures hockey jerseys for sale to college bookstores. The cost for X hockey jerseys is modeled by the function C of X. So gymnast clothing sells the jerseys at $90 each, so that's the price per jersey. Find the revenue. So revenue, you've probably seen in your business classes, is just the number of items sold times the price of each item. So this will be true always. This is going to be your revenue formula that we'll use. So in this situation, I have to find these two things. So the number of items sold is going to be X because it says that there's X hockey jerseys. We're talking about the cost for X hockey jerseys, so that's going to be the number of items that we're talking about. And they're selling for a price of $90 each. So the revenue, we use R, capital R of X, it's common notation to represent revenue, is going to be X times the $90, which normally we don't write it like that. We would write it as R of X equals 90 times X, just like this, 90X. It's not wrong to write it the other way, it's just not as common. So that's the revenue. So now to find the profit, whenever we talk about profit, this is equal to the revenue minus the cost. So we would call this P of X for profit is equal to R of X minus C of X. So again, this is something that you're going to see quite a bit in this class. So now if I take that, here's our subtraction example. So we're trying to find the profit. So take the revenue, which is 90X, minus the cost that they give us. Now notice I'm going to put this in parentheses. Because I'm subtracting, I want to make sure that I remember to distribute that negative. And no matter how many times I say it, it's always something that is easily messed up. So just be careful. So if you try to do this all in one step, that's fine, but make sure you remember each of these signs gets flipped. Otherwise, doing the parentheses is kind of just a visual reminder to remember to distribute that negative. So you don't have to show it, but it's very easy to mess up if you don't. So distribute the negative, and then I'm just combining like terms. So what I'm going to do from here is P of X equals in standard form. So it's going to be negative 0.2 x squared. This is going to end up being plus 80x when I combine my x's, and then minus 1500. And there we have it. There's your profit formula. And then, of course, you could plug in for X and figure out what's the profit if you produce and sell 50 jerseys, and you could plug it into that formula, that kind of thing. But we'll get into that later on. So the other example I wanted to look at is this example here. It says a manufacturer of hard shell cases for the iPhone knows the number of cases she can sell each week is related to the price of the cases by the equation X equals 1300 minus 100p, where X is the number of cases and P is the price per case. So what price, so we're trying to figure out the price, so we're trying to solve for P, should she charge for each case if she wants the weekly revenue to be 4,000? So first of all, think about the revenue. So revenue is going to be the number of items sold, so X times the price of each item. So that means I can't have a function where I have the input being X and then another variable. So what I'm going to do is I need to switch this. So I need this to be in terms of P. So what I'm going to do is I'm going to say R of P is going to be the number of cases is represented by this. So instead of X, I'm going to use 1300 minus 100p P times P. So now see how all of my input is P and all my variables here are P, it all matches. So this really, I should have just probably put R there because I shouldn't, I'm just gonna actually switch that because we shouldn't have all those different, the input has to match throughout the equation. But that's really just our formula. So anyways, if I look at this, now I can plug in the revenue has to be 4,000. So if the revenue is 4,000, now I can go ahead and distribute this. So it'll be 1,300p minus 100p squared. And from there, we just have to solve for p because we're trying to solve for the price. So that means I recognize this as something that I'm going to have to factor because it has a p squared in it, which tells me that I want to get this equal to 0. Anytime you factor, you got to have it equal to 0. So we're going to just go 0, and I'm going to bring that over. So it's going to be negative 4,000 plus 1,300p minus 100p squared. And then really what I want to do is get this in standard form. And I also see that I could divide all of these things by negative 100. If I divide everything by negative 100, it's going to allow me to get a 1 in front of p squared, which is what I want. I don't want to try to factor with some other leading coefficient. So I'm going to go ahead and just divide everything by negative 100. And then I'm going to kind of do some rearranging here. So I like to see the 0 on the right-hand side, not that it matters, but I'm going to put this first. So if I divide negative 100 divided by negative 100, that's just going to give me a 1p squared. This one, the zeros are going to cancel here, so I'm going to have negative 13p. And then this one, the zeros will cancel, so I'll have positive 40. The negative divided by negative, and then equals 0. So you could do this in as many steps as needed. I'm just trying to rearrange it so that it looks like something that can factor. So then for this one, you can use the grid like we talked about for factoring. I recommend when it's a leading coefficient of 1 just to go right into your binomials. So basically look for numbers that are going to add to negative 13 and multiply to 40, positive 40. This will end up being p and p. The only time that I really use the grid is when it's a leading coefficient not equal to 1. So then for this, numbers that are going to work are going to be negative 8, negative 5 would multiply to positive 40 and add to negative 13. So then from here, you want to split this since it's a product equals to 0. One or both of these have to equal 0. So you set each piece equal to 0. So I solve it, I get p equals 8 and p equals 5. So what this is saying is she could charge $5 or $8 and make a revenue of 4,000. So if you think about it, she would be best off selling for $5 because more people are likely to buy if she's selling for less. So she could charge she could charge $5 or $8 and get the revenue of 4,000. So to answer the question, you would want to give both answers because it's just asking you which price would she charge to get the revenue of 4,000, and those both work. So you're not really going much further into it. So you would just leave it like that. And keep in mind the reason why there's two answers is because this is a quadratic, so it's a parabola. It's actually an upside down parabola. So she's not making the maximum revenue. So maximum revenue would occur up here and there'd only be one value. So she's somewhere like maybe in here where she's getting, that's why there's a $5 and there's an $8 that are giving us the same revenue. So that's kind of the visual of why this is working.